up for 1 and show you how to use your calculator that you don't have. Show you how to use your calculator to get to the answers without writing too much down on a piece of paper. So this has to do with I want to do conversions on a calculator, converting from our numbers into their numbers. What is our number system called, basically? Hindu Arabic base 10 numeral system. It's a big fancy long name, but we usually abbreviate it as Hindu Arabic or HA. HA works perfectly fine. Theirs can be anything. It could be mine, it could be Babylonian, and then more stuff today. More fun stuff today. So, last week, I showed you how to convert things like 7,321 into a Mayan numeral, into a Mayan number system. And the way we did it was, the question you always have to ask is how many place values in their system? I could care less about our system. Ours has 4 place values, but does that help me answer the question? No. So in Mayan, we don't know how many place values it's going to be until we start working it out. So we have the 1's place. Next to that is the 20's place. Next to that is 360's place. And next to that is... No, that's Babylonian. How do I get to the next one?
72,000.
360 times 20. 7,200? 7,200. Okay. If I go one more and I multiply this by 20, it's going to be much bigger than 7,300. This is really close to it as it is. So if I did go one more, I'd eventually have to cross it off. I think it's 144,000, if I remember right.
So you will multiply the 7,200 times 20?
Yeah. To get to the next one.
And then the next number will be that
times
number
20. Yeah.
Okay.
After that 360, it just goes back to multiply by 20. All right.
Just regular 20, or is it like 20 squared if it goes from...
No. If I get this number, I multiply it by 20 to get to this number. Then I take 7,200 and multiply it by 20 to get to the next one. I don't worry about the square thing. Not with mine. All right, so since I went too big, I back off and I say, 7,200 goes into 7,321 one time with a remainder of 121. So where does the 1 go? Above 7,200. Where's the 121 go? It gets divided by the next place value, which is 360. So does 360 go into 121? The answer is no, so that means it's 0. It's 0, goes in 0 times, and it has a remainder of 121. So I put a 0 here. There are 0 360s in this number. Okay. So what do I do with that 121 now? Divide by 20. How many times does 20 go into 121? 6. And 6 times 20 is 120, and that leaves us with a remainder of 1. So I put 6 here and 1 there. So my Mayan numeral is 1061. But it's not 1061 because it's not base 10. How do I write 1061 in Mayan? Mayan only has 3 symbols: dot, line, and the bowl.
A dot?
A dot.
It goes vertical.
The empty basket for 0.
And a dot
A dot and a line for 6. And a dot all by himself down there at the bottom. So this numeral right here represents 7,321. What's wrong with this method is this. Way too much writing over here to the side. Plus, you also, if the numbers get uglier, you also have to multiply down, get an answer for down here, then you have to turn around and subtract those 2 numbers and finally get to your remainder. It gets kind of tedious. So here's another way of thinking about it. On your calculators, do 437 divided by 13. I'm just curious. This is just something.
Put what now?
437.
Just do 437 divided by 13 on your calculator. I'm hoping it comes out ugly.
Yeah.
Yay! 437 divided by 13 equals 33.666 something, right?
Yep.
33.61. 3.846 something. Okay. The 2 could be a 1, it could have been rounded, so I'll just leave it off. But this decimal goes for a very long time. Maybe not forever, but definitely for a very long time. Or it would start repeating someplace, but I don't see it repeating here. But it does terminate, it is a rational number. Or it does repeat, one of the two.
No.
But here's the thing. This is the number we're interested in. The 33. That would be the numbers that we put on top of my lines over here. What about that 0.61538? What the heck is that?
Wait, what is that?
What is it?
Your remainder?
Wait a minute.
It's my remainder, but it's hidden. It's an ugly decimal approximation of what my remainder should be. So here's my next thing. If I do this longhand, I put 13 up here, then I have to go, well, not 13, 33. If I put 33 up here, what's 33 times 13? 33 times 13 equals
429.
429. And then when I subtract it, I get a remainder of 8.
Yeah.
So what does this mean as a answer? What does all that mean?
It doesn't mean anything.
Yes, it does.
It's not finished.
It is finished.
Take
It is.
33.
13 goes into 437, 33 times with a remainder of 8. But what is the answer? Well, it's 33 and...
33 and
1 8. Remainder 8?
No, come on. Don't you all know how to do anything with fractions?
Oh, 8.
Oh,
8 over 13.
8 over 13.
Yeah, that's it.
The answer is 33 and 8/13. 8/13.
What?
What do you mean, what?
You're not going to have us be right answers in fractions.
No.
Oh.
I'm trying to get you an idea of, there's a correlation between this 33 and 8/13 and this decimal answer that your calculator gives you. These two things are exactly the same thing. And notice they both have a 33. So the decimal part must be 8/13. So do 8 divided by 13. Check out the answer. 0.615384615.
So,
That 2 was really a 1, but...
So what is this?
Hold, I'm getting there. Be patient. I'm trying to teach you something that you should already know, that there is a relationship between rational numbers and decimals. But what does this have to do with
Nothing.
that? Oh, yes, it does. Otherwise, I wouldn't show it to you.
That's my
So
question.
that port 2 goes up.
Yeah, but I don't care about that. What I care about is 8/13 is this decimal answer.
Yeah.
Okay. So, just like over there, I ignore the answer and I put it up on top of the line. So if I ignore the 33, how do you do that on a calculator? Ignore 33. Subtract it.
So try 30.
Subtract 33, and then you're left with just the decimal. No, you have to go back up here. Do 437 divided by 13. 437 divided by 13. Subtract the 33. And you should be back to that decimal of 8 over 13. The number that I'm interested in is 8. That's all I want out of this whole mess. All I want is the remainder. The 8 here is above this 13. So how do I get rid of the 13?
Subtract.
You can't
Flip it.
multiply by
The ratio.
13.
over 8.
What happens to the 13?
You cancel.
What are you left with?
8.
Take the decimal answer in your calculator and multiply it by 13 and see what happens.
8.
Turns out to be 8. So the technique here is divide your numbers like normal, subtract away the whole part, and multiply by what you divided by. Okay, so 1, divide, 2, subtract, whole part, and 3, multiply by what you divided by. This will always work. So ready? Let's try another one. Let's kind of match it up to that one over there. 14,387, and I want to make it a Mayan number.
Mr. Flores?
Yep.
Is this supposed to be the shortcut?
This is the shortcut.
It don't seem like
This
it.
is the shortcut.
I'd rather draw the pictures.
You can't draw the pictures until you get the numbers.
What did you do?
I'm going to do 14,387. I want to change it into a Mayan numeral. Now, If I go one more place value above 7,200, it's 144,000. That's obviously less than 144,000. So in Mayan, this is only 4 place values. The 1s, the 20s, the 360s, the 7,200s. Okay. I'm not going to write that much down on the board. It's mostly going to be done in the calculator. So clear off your calculator and get ready. The only thing I hate about teaching the calculator is I'll have some people following me, and then I'll have other people lost in space, and then they want me to bring them back into following me. So make sure you just follow, wait for your questions until later. The first thing you're going to do is 14,387, and you're going to divide it by 7,200. So 14,387 divided by 7,200. Hit equals,
1.9.
and you get 1.999. We don't care about that. All we care about is 1. So far, so good?
Yeah.
All right. Subtract the whole number, which is 1, hit equals. Basically, all that does is it gets rid of the whole number and leaves you with just the decimal. All right? We divided by 7,200, so we're going to take this decimal and multiply it by 7,200 and hit equals. What do we get?
7187.
This is the remainder, 7187. I'm going to put it in parentheses because it's really not part of the answer. It's just the remainder after division.
Wait. You lost me at the -1. Subtract 1.
Subtract 1, and then turn around and multiply by 7,200. Like I said, keep with me.
I'm lost. When you divide it.
Excuse me? 14,000 divided by the 7,200, you get 1.9. This is why you don't use a cell phone calculator, and then multiply by 7,200. Catch up to us now. Just start with this number.
Okay.
What do I do with 7187?
Multiply those two divided by.
No, this is my remainder.
You subtract that
Divide by 360.
You move to the next place value and divide by that number. So I take 7187 and I divide it by 360. So 7187 divided by 360 equals
19.
19 goes up here.
-19.
Minus 19 on your calculator. Don't forget to hit equals and multiply by 360.
Then go back and multiply by 360.
And you turn around and multiply by 360.
Then you divide by 20.
Now you do not get ahead of me. You stay with me. Now, we got our remainder of 347. Is everybody there?
Yes.
Why not? Did you
Did
do 7187 divided by 360?
Okay, let me do that again.
I got
Okay, I got 19 something.
All right, the 19 goes up here.
Okay.
Then on your calculator, just hit minus 19, it equals.
Okay.
And then multiply by,
360.
and you should end up with
347.
347. What do I do with the 347? Well, I divide by 20. So divide that by 20 and you get 17 is the number I care about. What do I do with the 17? Minus 17, it equals, and multiply that answer by 20 and you get.
20.
Now, I got 7. And there's a reason I got 7 is because when I get these remainder numbers, I retype them in my calculator. If you do not retype them in your calculator, what happens is you're getting approximate answers flowing through your calculation, and eventually it shows up, and it usually shows up at the end.
Do I multiply
Now,
by 20?
if you do end up with 6.999999 or 7.00001, it's the last answer that you're looking for. It has to be a whole number. Just write it down. If it's the last number, you can round it. Only if it's the last number, though. Right. 7187 divided by 360. Subtract away the 19. It equals times it by 360.
Okay, I got to the 17.
Okay.
And now I subtract 17. I got 0. I got
Point something,
0.35.
something, something. Yeah. Multiply by 20. So when I write this in Mayan, 1 19, 4.3 bars. 17 is,
3 bars, 2 dots. Subtract 20.
and then finally 7. So this numeral is 14,387. 14,387.
So, Mr. Taylor, not give me back here.
Go ahead.
How did you get 7?
Yeah, that's right.
When I did 347 and I divide by 20, I got 17.
I got that part.
Subtract 17 and multiply by 20.
Okay.
That gives you 7.
For the last number, that's what I'm talking
But see, this is 7. 1 goes into 7 how many times?
That's what I was trying to figure out.
7. With a remainder of? The last one is always going to be that last remainder. Whatever it is. The ones. Divide, subtract, multiply.
So, Mr. K,
Mhm.
I need to go to your video 4.1 to find out about the dots and the lines.
Highly suggested. Okay, Babylonian. Let's change something horrid. Oh, 300, 5,207, and I want to change it into a baby number. Babylonian. 305,207. Now, what do I not know? Yeah, I know that. How many place values are we talking about? I know ours is 6, but I could care less that ours is 6. I'm more worried about the Babylonian. So the Babylonians start with 1s. Next one up,
60.
60s. Next one up,
60 squared.
better known as 3,600. You need to see the values of these. So if you're writing 60 squared, 60 cubed, that's not going to help you because we won't know when we get bigger than 305,000. Next one up is?
60 cubed.
Yeah, but what is it?
216,000.
216,000. And the next one up is? It's too big. It's 12 million something. It's 12 million. So 12 million is too big. So 216,000 is the first thing we're going to divide in. So you pick up your handy dandy calculator and you type in 305,207 divided by 21600. And you get a magic number,
1.
which we were expecting anyways, 1. The 1 goes up here. What?
Go ahead. I did so wrong.
Okay. What do I do with the 1 on the calculator?
Minus
Subtract 1 and hit equals. And then turn around and multiply that by
3,600.
216,000. You multiply by what you divided by. We divided by 216,000. Hit equals and you get 89207. All right. That's the remainder. That's the remainder.
Okay, 305,
207 divided by 216,000. Hit equals.
and then that's what I got on.
And then you go minus 1. Hit equals. And times by 216,000. All right, what do I do with 89,207?
Divide by 36.
Divide by 3,600. Don't do by 360. And you get
24.
24. So you put the 24 up here. On your calculator, you minus 24, hit equals. And then you turn around and multiply that decimal ugly answer by 3,600. And you get 2807. And that would be your remainder. Then you take this remainder and you divide it by 60. And you get?
46.
And you put 46 up here on your calculator.
Minus
Subtract 46 and multiply by,
60.
and this should be our last number.
47.
47. Because it comes out ugly, but it is the last number, so you just round it. 1, 24, 46, 47. I didn't plan on that. I was hoping they'd be smaller numbers.
Sure you did.
89207 divided by 3600. Hit equals. Subtract 24. Hit equals. Multiply by 3600. The pattern never changes. Yeah. So 1 in Babylonian,
Triangle upside down.
24 in Babylonian,
2 arrows and 4 triangles.
46 in Babylonian.
4 arrows.
50 minus 3.
Oh,
Yeah, you can do that too, but I'm going to go the long way. And 47, I'm going to do 50 minus 3. So there would be 1, 24, 46, 47.
But that second long, with the first long one that you put, can't we still do that with the subtraction?
Yeah, you can do 5 minus 4.
Mr. K, instead of the little, making it a whole triangle, can you just make it like a V? That's what I've been doing.
You can if you want. I like my little triangles. Because technically, the way the book types them, because typing and actually what it looks like are 2 different things, they really do look more like this. Of course, my 10s, I shorten them.
That's how I was
They would
gonna say,
take
I
two.
get everything up to that last one.
The symbols, yeah, you'll get used to it. All right, today's lesson. The real part of it.
Mr. Flowers, this part of 4.1.
This is part of 4.1, but it is also part of 4.2, because guess what 4.2 does? Same stuff. For instance, 4.2. Other bases. 4.2 is about other bases. We've actually dealt with other bases except for one problem. The problem with Babylonian is it didn't have a symbol for 0. The problem with Mayan is their base system kind of changed at that 360 spot, but they did have a symbol for 0. But they're not perfect place value systems like ours is. So let's start off with ours. Ours is base 10. And trust me, I will not ask you for base 10 answers. I'll just say ours, and you'll write it like a normal number. Now, when we're talking about base 10, we have symbols. You know, those Hindu Arabic symbols, and they go all the way up to 9, but then they include that symbol for 0. Now, there's something to notice about our numbers. We have literally 9 numbers and 0. So there's 10 symbols, but one of them has absolutely no value. One of them has absolutely no value. So if I ask you to give me symbols for base 5, the first symbol that it has to start off with, I'm going to put the 0 there. All bases have a 0.
So when you say base 10, you're referring to what's in that set?
Yeah.
Okay.
The symbols are in that set.
Yeah.
But then we have a base 10 system, which is 1, 10, 10 squared, 10 cubed, 10 to the third, and so forth and so on.
It'd be 1, 2, 3, 4.
It would be 1, 2, 3, 4. It has 5 symbols, but one of them has to be 0, so its maximum value is 4. Okay. What about,
Okay, so when you say base, you're not including that number?
that's another way of looking at it. Because look, base 10, we don't include 10 because we have to write it as 2 symbols. Same thing for 5. To write 5, you have to write 2 symbols. And this one here, base 3, would be 0,
1, 2.
1, 2. So what's the lowest base we could have?
1?
1, 0.
No, because base 0 would have no symbols.
Base 2.
Base 1 would have 1 symbol, but that symbol would have to be 0, so the only number you could write is 0, which is kind of trivial. So base 2 is the smallest one. So the base 2 system has 2 symbols, 0 and 1. Here's a base 2 system right here.
Keep it like
Oh, by the way, this is 0, right? No light. This is 1. This is 2. And that's 3. So light switches are actually a base 2 system. What else is a base 2 system? I can point to it. Computers. Computers only understand, just like the lights do, on and off. Actually, computers understand high voltage and low voltage. If you've ever seen, when I was first learning computers, their switches would say this. And you would go to the computer and you go, oh, on is up and off is down. And then later it changed into this, and you had to kind of figure out what the heck they were talking about. They made it a 1 and a 0. And 1 means on, and 0 means off, which is kind of cool. If you think about it, it relates directly to what a computer is. Yeah, that's why. That's long ago. Of course, nowadays it's just that little round button you plug in and punch
It
in.
still has that symbol.
Does it still have that symbol on it? And it's kind of cool if you think about it. So a computer, anytime you use a computer, turn it on, run a program, do any typing on it, it's sending commands that are all based on a bunch of zeros and ones, and it finds them. I mean, millions and millions of calculations per second. It's kind of cool if you think about it. But they're a pain to work with for us. As humans, we're used to base 10. All right, the other tricky bases are this. What about if we go bigger than 10? What if we do base 12?
Base 10.
Base 12.
Base 10.
No, it's not base 10, it's base 12. So how many symbols do I need?
11.
I need 12 symbols.
0.
Zero.
I only have 10 though. So I'm going to start with 0. 1, 2, go all the way up to 9. But I'm going to need 2 more. I need 2 more symbols. And I'm going to use A and B. Personally, I use A and B. The book uses T and E.
Use what?
I use A, B, capital letter A, capital letter B. The book uses T, E. What do you think T represents?
10.
What do you think E represents?
Even.
11. But I like AB better because later we're going to use AB as 10 and 11 anyways.
And they use AB because it normally stops at 9, right?
Right, this would be 9, this would be 10, this would be 11.
Yeah.
That'll give me 12 symbols
Yeah.
with a 0. With a 0. So that's one thing. Base 12, you have to add in symbols that represent numbers, but we usually use them as letters, which is kind of weird.
Do we get high? Does it get higher?
Yeah, base 16.
Oh, you go further down the alphabet?
No, you can't go further than the alphabet. If you do, it would be really weird. But base 16 is as big as we get. So it starts at 0, goes all the way up to 9, and then you have to have 16 symbols. I have 10.
Yeah, for the AB.
I need how many more? 6. So I need 1, 2, 3, 4, 5 symbols more. There we go, 6 spaces. So what we're going to do is we're going to use A for 10, B for 11, C for 12, D for 13, E for 14, and F for 15. I said no to what though? I probably heard one thing said no, and
I
they all
said
thought I was talking to
we keep
you.
going on the letters.
What's that?
I said we keep going with the letters.
Yeah, we'll keep going with letters, but not forever. We'll stop at F. So this is 10, this is 11, this is 12, this is 13, this is 14, this is 15. Whenever you're dealing with base 16, I highly suggest you write out the blue letters, and under them or over them, write in our numeration system for them. Because there are times when I see C and I don't remember what it is, so I'll have to go A, B, C, 10, 11, 12, get to the right value of it. Now, you have seen base 16 before if you have worked with Windows 95. You remember Windows 95?
Mm-hmm.
And it would go to that blue screen and it would have all these numbers and letters on there. And the letters were A, B, C, D, E, F, and never went any higher than that. Those were computer language hexagonal. They convert binary into hexagonal because hex numbers, these are called hex numbers, are smaller. They take up less memory than binomial numbers, which are actually very, very long, and they represent the same thing. So base 16 is also a computer language thing. It converts base 2 into base 16, and then it makes things compactor, smaller. Less memory space. Okay, so let's work with some of these bases. And we do the same thing as we did with Babylonian and Mayan. We're going to convert from theirs to ours and ours to theirs. It's the best way to learn a language. Okay. So we'll start off with something somewhat simple. For example, if we have 4, 3, 2, base 6. Now the book does it a little bit different than me. I just write a little 6 subscript. The book writes SIX. I just hate writing out a lot of words. So when I write this little number here, it's not part of the number, it's just telling you what base it's in. So this is read, literally, in English, 4, I'll write it out in English, 4, 3, 2, base 6. It is not 432. It is absolutely not 432. If you read this as 432 base 6, you are absolutely wrong. It has to be read 432 base 6. You have to understand that it's not our number. So the question that comes up is, how do I convert this into our number? Well, the question is, how many place values in their system? 3. They're staring at me. Once they're staring at me, we know this is an easy problem. This is the 1's place.
Then 6.
This is the 6's place.
And 6 squared.
And this is the 6 squared place, better known as 36 if you wish. What are the digits in these place values?
4, 3.
I know because they're staring me in the face. This is 4, this is 3, this is 2. I don't need to do division here. I need to do multiplication. This is the biggest mistake people make. They're not sure which one they're going to be doing. So the first one is 4 times 6 squared, or 36, plus 3 times 6, plus 2. Put it away.
I believe when my son started getting sick.
Oh. Was he texting you every 5 minutes?
No, the person who's watching him is texting me.
Why?
Because I want to make sure my son's okay.
But someone's watching him.
So.
Oh my God. What are they going to kill him and text you? I killed him. What is it? 164. So 432 base 6 is equal to 164.
That's how we gotta write it out.
No, but I'm telling you that they're equal to each other. I just want the 164.
So when it says base 6, that lets me know that I have to square.
Well, your bases are going to be a bunch of 6s.
Now, you
The
know-
square automatically comes into play.
So if you had another number from that 4, you just do 6 cubes?
Oh, you want to see? Ready?
Oh.
102,012 base 3. Yes, brother.
Okay, when we did the 164, then we do, if we put the base 6, we do not have to put the base 6.
Please don't, because that's 164.
Okay.
Where this side is 432 base 6, but they represent the same value.
Okay.
If I wrote you a check for 432 base $6, I'd be writing you a check for $164. Though banks wouldn't appreciate that. So the question here is, how many place values?
6.
6, because it's in base 3. I know there are 6 place values. So the first one is 1s, always the 1s and nothing else.
Why do you know it's 6?
1, 2, 3, 4, 5, 6 in base 3. I know there are 6 place values in base 3. I only care about their base.
So, their base number, it could change.
Yes. Well, that one's 6 over there. This one is 3. So the 1s are here. The next one up is 3. The next one up is 3 squared. The next one up is 3 cubed. The next one up 3 to the 4th. The next one up 3 to the 5th. If you like regular numbers, this is 1, 3, 9, 27, 81, 243. All right. And now all you have to do is put in the digits. The first one gets a 1, 0, 2, 0, 1, 2. Because that's the place value we're in. We're in 3s. In your calculator, you need 3 to the 5th, 2 times 3 squared, 1 times 3, 2 times 1.
302.
Because the zeros are going to just make it 0, so we don't care about them. That's all we care about. The expansion of it. And this is equal to what?
302.
301.
Which one?
I ain't tried.
I got 301.
Did you do plus 2 or plus 1?
I got 302.
Oh, I think I did.
302.
302? So this is 302, but that's the same thing as 102012 base 3. They have the same value. They have the same value. All right, one for you. Oh, before I give you one, let me write something down and you tell me what's wrong with that. What's wrong with that number? That numeral?
You don't have 3 place values.
I don't care about that.
The last number is odd? I mean, yeah.
I could care less if it's odd.
It's like 4, 5, 6, 7.
Decimals.
What's wrong with that number? 4, 5, 7, base 6.
It's together.
So are all these other ones.
What's
There's-
wrong with it?
There's something wrong with it. Come on.
Let me see him. 1, 6.
Cause that 7 need to be a 6.
That 7 is too big.
Oh, yeah,
Why
last
they-
number can be higher.
This 7
Can't be higher than that.
is not a symbol in base
Oh,
6. It's impossible. You can only have the numbers, the digits, 0, 1, 2, 3, 4. 5 is the biggest one. There is no symbol for 6, and there is no symbol for 7. So if you're ever doing conversions and you write something silly like this down, you know you did something wrong. It's really important that if you're putting a base 6 here, all the numbers to the left of it better be smaller. Better be smaller than 6.
So before they even start the problem, you gotta know what numbers.
No, if I give you a problem, I'm going to make sure I write it correctly. The problem happens when you convert ours into theirs. I've had people write this as their answer.
Yeah.
But it makes absolutely no sense because there is no 7 in base.
So all numbers have to be smaller than its base.
Smaller than its base, yes. All digits have to be smaller than its base. Okay, how about you guys do this one? That one's legal. All the digits are smaller than 7. Tell me what 4, 5, 6 base 7 is equal to. You're- $237.
Oh, I don't know where the came from.
237.
I'll put it on there.
Because there are 3 place values here. The first one is the next one is, the next one is 7 squared, 49, either way you want to look about it. The digits are 4, 5, and 6, so it's 4 times 49 plus 5 times 7 plus 6 for a grand total of 237. Awesome, you got it. How about this one?
Oh, come on. What, can you do that? It's not legal.
423 base 12.
Can you do that?
Why not?
How can you multiply?
Shh. Why can't I do base 12? I gave you symbols for base 12, right?
But you don't have a number.
You got A and B.
A Hindu number.
T, and E, whichever
Oh,
one
you
you
gotta
want.
do the A.
But those aren't all the numbers for that base.
I don't have to write all the numbers for the base.
So
Did I
how
write
do
all the
you say
numbers for
something
base
times A?
I got 603.
Where you get A from?
Did I write all the, well, actually that one I did. Did I write all the numbers for
That's
base
what I was
6 over
saying.
here? No. Yeah, this one I did because there's only 3 to work with. But this one I have 12 symbols to work with and I just chose 3 of them.
You said 603?
Yeah.
The technique does not change when things look different. The technique stays exactly the same. How many place values? 3. This one is the 1s. This is the 12s.
12 squared.
This is 144 or 12 squared. And then top it goes 4, 2, 3. So you go 4 times 144 plus 2 times 12 plus 3 for a grand total of 603. Don't write any base after this. This is 603. It's understood to be base 10, but don't write it. It's just understood.
Well, how you get base 10 out of 603?
Because this 4 represents 4 144s, and 144 is our number. So when I go 4 times 144, I'm converting it into a value that I understand. 144 is something I understand. 4 7 squares, I don't understand. Oh, 4 times 144, I did. Alright, how about this one?
You know what though? I know what it
I know what it means.
I know what that means too, but if you see this and there are letters involved, I actually would say if you see base 16 anywhere, go off to the side and go A, B, C, D, E, F. Underneath it, write 10, 11, 12, 13, 14, and 15. So you know what the values of these letters are in our language. It's a nice little conversion over. How many place values in their system?
4.
4. So you go 1, 2, 3, 4. And the bases start with 1. Never start with the base value. It's always going to be 1. Next one over is?
16.
Next one over is? 16 squared or 256. The next one over?
4,096.
16 cubed, 4,096. Okay, what goes in top?
2,
2.
11, 3, and 14.
2,
A.
10. I don't need to write A because I don't know how to type A in my calculator. But I do know how to type in 10. 3
And 14.
and 14, because E is 14. So on my calculator, I'm going to type in 2 times 16 cubed plus 10 times 16 squared plus 3 times 16 plus 14.
10,008.
1 million.
Is that right?
A million. 10,000.
805.
805.
I got 805.
805.
Is it 805 or 14?
10,814.
That's what I
Oh,
got.
well.
Oh,
Who,
yeah, that's
who's
right.
giving me the wrong answers all the
Me.
time?
I keep forgetting about that 4. The last
10,814. Our number. What's kind of cool here is in base 16, it took 4 positions to write the number. In our system, it takes
6. And then
5. Worried. I am really worried. Of course, this is the easy way. This is the easy way. This is not the hard way.
Used to.
Okay.
The hard way is division. So guess what most people concentrate on?
That way.
Division. And guess what they forget?
To multiply.
The easy one. And they screw it up and do them backwards. One more for you, and then we'll do the backwards way.
Everybody get it. The fans was hollering it out. Those ain't got it yet.
I can't see.
Is that a bomb?
That's binary. And binary is only hard because there's only 2 symbols to write. A 0 or a 1. So that makes numbers very difficult to write largely. This is not a very big number. It's just very long for you to calculate out what the heck it
You
is.
got short way.
There is no short way.
Oh.
Yeah, do all of them.
So you don't do this like the ones you just been
You
doing?
do it exactly like the ones you just did. It just has a little bit more place valuage. Place valuage. I think there's 8 of them.
It is. Ouch. I got 153. Oh, yeah. Is it right?
What?
153.
153?
You got it.
Yes.
I was about to say, why you looking like that?
Trying to make you doubt yourself. Yes. Supposed to be 153. 153. Supposed to be. I worry if it's not. This is the 1's place. Next one up is 2. The next one up is
2 squared.
2 squared, better known as 4. This is 2 cubed, better known as.
8.
This is 2 to the 4th, better known as
16.
16. This is 2 to the 5th, better known as
32.
32. This one is 64. And this is 128. Hey, did you notice something about those numbers? It's 1, 2, 4, 8, 16, 32, 64. It's doubling, but have you ever watched like computer memory? It usually goes, you start off with 1 megabyte, and then your computer has 2 megabytes. It never goes to 3, it jumps to 4. Once it gets to 4, it goes to
8.
It's weird how things like that work, but this is computers. Computers work on 1 and zeros, which is kind of cool. So this all multiplies together to give you 153. The cool thing about binary is this. If it has a 1, it's just the base you're worried about. If it has a 0, you can care less about it. So all I did was go 2 to the 7th plus 2 to the 4th plus 2 to the 3rd plus 1, and I got my answer. That's the beautiful thing about binary. That's the only thing that's good about binary. So where do people make their mistakes? Do they make it with base 16? Or do they make it with binary? Binary. Why? Because it's way too easy. And that's the danger of it. The easy ones are the ones that will hurt you.
10/3.
Getting there.
It's 10/3.
2 to the 7th, which is 128, plus 2 to the 4th, which is 16, plus 2 to the 3rd, which is 8, plus 1. So it's 128 plus 16 plus 8 plus 1. All right, let's go the other way.
Oh, I know what I did.
How do we know which way to go?
I have to tell you. Oh, by the way, there is nowhere else to go with this but to our numbers. But if I give you this, then I'm going to tell you what I want it to convert to. So if I don't tell you anything, just convert it into our numbers. If I do tell you something, I will tell you what I want you to convert it to. All right, so how do I convert our numbers into theirs? Do I multiply? Probably not, because that would be theirs into ours. So it must be the other one, which is divide. So this is automatically a division problem. And the question stays the same. No matter if you're multiplying or dividing, you're always asking, how many place values in their system?
7.
7 is in our system. How many place values does 7 take in base 5? I don't know. So you start off with the 1s. The next one up is
5.
the 5s. The next one up is 25, which is way too big. And then everything is just division. But this one I don't need to do on my calculator. 5 goes into 7 with a remainder of 2. So 7 to us is 1, 2, base 5 to some space alien. Or some person that only counts on one of their hands rather than both of their hands.
So if we reverse it and check it, we should come out with 7.
Oh yeah, sure. This is 1s, this is 5s. 1 times 5 is 5. 2 times 1 is 2. 5 plus 2 is 7.
So, Mr. K, we only need the place value for 5 because you're going to base 5. It was going to like base 7 or something, we'll put 7. So, okay.
Say that again, 1 times 5 is what?
1 times 5 is 5. 2 times 1 is 2. 5 plus 2 is 7. How about this? I'm trying to keep it easy for a second. Convert 13 to base 12. How many place values in their system? I don't know. So you start off with the 1s, the next one up is 12s, the next one up is 144s, which is way too big.
1 and 1.
12 goes into 13 1 times. 1 goes in, or with a remainder of 1. So 13 to us is,
12.
don't say 11.
1, 1.
1, 1, base 12. You say 11, and guess what?
Can we put B, base 12? For
Please,
what?
what? No,
That's only base 16.
I see.
Why not?
because B is 11.
I mean C. I meant C.
No,
Base
you have to
12.
write 12. You have to use our numbers. Our numbers. So 13 is 1, 1 base 12. All right. 1 times 12 is 12, plus 1 is 13. Now those are the simplistic ones.
What?
Let's go for the horrible ones. For example, 42. 2 base. 2.
You just did it, 'cause I said,
No, because as I went big, they kept dividing into it evenly, and I didn't want that. Base 2. So I don't know how many place values it's going to take, so you start with the 1s, build up to the 2s. Saying 2 squared is not helping me, so I'm going to write it as 4. The next one up is 8.
16.
We're not squaring all the numbers, we're multiplying them by 2. 2 times 8 is 16. 2 times 16 is 32. If we go one more, that's 64, but that's too big. But I want to go too big. If I don't go too big, I might go too small, and that's a danger. And now 32 goes into 42 how many times? Once. I don't even need a calculator for this. This is easy. Goes in once with a remainder of 10. 16 goes into 10. It does?
Don't listen to me.
I won't listen to you. 16 does not go into 10, so I write 0.
I'm just written out.
8 goes into 10. Once with a remainder of 2. 4 goes into 2. It doesn't. 2 goes into 2 with a remainder of 0. So my number is 101010 base 2. That's the same thing as 42. 101010 base 2. Because whatever comes out of it, that's the answer. I mean, not much to do to it. So let's get to a calculator one. That's nice. 1050.
I don't know why I thought we got out of here too.
1030. Where'd I get what?
10. Right below 32.
There is no 10. Oh, this 10. 32 goes into 42 once. When you subtract them, you get 10. That's the remainder. I put remainders down here. All right, calculator one. 3,218, and I want to change it into base 12. Now this one I can't do in my head because the number 1 is too big, and it's just messy. So we start off with, I don't know how many place values. So you start with the 1s, you build up to 12. Next one up is 144. Next one up is 1728, because you multiply 144 by 12. The next one upward is going to be,
Too big.
it is, because even 10 times this is much bigger than 3,200, so that's going to be too big. All right, and then you take your calculator and you do your magic. 3,218 divided by 1728 equals 1 time. So on top you put 1. Then you subtract 1 and hit equals. And you multiply by what you divided by, the 1728. And you should get 1490. Yay. What do I do with the 1490? Divide by 144, hit equals, you get 10 goes up here, but on your calculator you're going to subtract 10, hit equals, multiply that by 144, and you get 50. 12 goes in, when the numbers get small enough, don't use your calculator anymore. 12 goes into 50, 4 times. 4 times 12 is 48, that leaves you a remainder of 2. Now, how do I write this number, this value, this numeral, so that it is equal to 3,218? 1. A for 10, 4, 2, base 12. You cannot write 11042 because that takes up 5 place values, and we really only have 4. So it has to be 1 symbol per place value. So when you go above 10 and 11 in base 12, you have to write A and B or T and E, one of the 2. Alright. This isn't that bad, is it?
I can get it here.
3, 2, 1, 8. divided by 1728, it equals, oh. And you get 1. You subtract 1.
This is the final concept for today.
Subtract 1. Minus 1.
Right.
698 to base 16. I think this will work.
Nope.
Okay.
Oh. No, I'll just leave that for now. That's fine.
That's not 22.
You cannot use symbols that are two place values. You can only use single digits. Single digits. In base 16. This is the 1s. This is the 16s. This is the 16 squares, better known as 256. This next number is going to be way too big. I mean, way too big. So, 256 goes into 698 with a remainder of 186. 16 goes into 186. 11 times with a remainder of 10. When you write this down, though, it's got to be 2 B A base 16, not raised to the 16.
I said it was real.
2 B A.
Okay.
I haven't got a place value.
There we go.
Oh my God.
For example, 462095,
Hello.
and I wanted to change it into base 16. And thank God you have calculators.
Oh, God.
I want you to convert 462,095 into a base 16 numeral that has the same value as the given number. 70D0F base 16. And the reason for that is, if you're in base 16, it's going to take up 4 place values. What's this, 256?
Yes, 256.
And this one is
4,096.
4,000.
Take that 5.
Oh, it does?
Yeah, 4096
4096
and 65536.
and 65536. Ugh. Well, 65536 goes into 462,000 7 times with a remainder of 3343. Problem. When you do 4096 into this number, you get a big fat 0 because it does not go into it. Do not switch the division around. I've seen people do that. Keep the number on the outside as your base. Then you take 3343 and divide by 256,
13.
and you get 13 with a remainder of 15. Obviously 16 can't go into it, so you get that. Now be careful. It's 7, 0. When you get to 13, 10, 11, 12, 13, A, B, C, D. So you get D here. 0 again, and then 15 is one less than D, which is A, B, C, D, E, F. A,
So
what?
less than D is 2.
Oh, to the right, F. Don't mind me. Shh, quiet. And you get that as your answer. 70D0F. That was one right there. Homework!
I'm about to confuse myself.
All the checkpoints in 4.2. All the checkpoints in 4.2. You might want to go back. Well, I don't think they asked.
We can do the base to a base.
You want to convert a base to a base.
No, we don't want to convert a base to a base.
Oh, I'll tell you how to do it. You ready?
No.
You take the base that they give you, you convert it into base 10. And then you turn around and take the base 10 and convert it into whatever base you want to.
What?
Come on.
No, I need to know. This is the homework now.
If you have
This is the homework. I need to know.
1, 4 base 5, and you want to convert it into base 12,
Yeah.
right? It's not going to be a very friendly thing. The first thing you do is you convert it into base 10. To convert it into base 10, it's 1 times 5 plus 4, better known as 9. To convert 9 into a base 12 system, that's easy. That's just 9. So there has to be a commonality between them, and that commonality happens to be base 10. So you take whatever number they give you, convert it into a base 10. That'll be multiplication. And then you take that answer and you change it into whatever base you need
So
to.
whatever these
That'll be
base-
division. So you're gonna multiply first and divide on the back end of it. Do you wanna make it longer? 104, well, 104 base 5, and I wanna change it to base 7. Okay, so what's 104 base 5 as our number?
What, 1 times
Well,
5 plus 4?
This is 1 times 25 plus 4.
Why not?
This is the 1's place, this is the 5's place, this is the 25's place. So it's 1 times 25, which is 25. 25 plus 4 is 29. So that's our number, 29. And then convert it into a base 7, that would take up 1, 7, 49 is way too big. 7 goes into 29 4 times
With a remainder of 1.
with a remainder of 1, so it would be 4, 1,
Base 7.
base 7.
Okay.
So convert it to base 10,
Gotcha.
then base 10 into
Okay.
whatever base you want. It doesn't matter after that.